Alright, so welcome to Astroboden. Sitting down there in the rain. Yeah. Well, inside the garage here, it's nice and dry. Looking at the Lucid Mount here. Yeah, standing without the OTA attachment. So I've been thinking about how to go ahead. If you can, just for a quick reference, this is how the right ascension works. Yeah, kind of wobbly. Declination doesn't have the same leverage arm, but it's also not the strongest thing. Nice, completely still evening. It's okay. It actually runs fine. I've done one of my better Andromeda images, etc. on that. So yeah, it's fun enough for me to carry on with, but I have to think about how to go ahead. Yeah. So these motors that we can see here. So said before, this comes from a hoverboard, so the 350 watt 36 volt BLDC motors, yeah. And well, they've been working quite well, but I run them on 12 volts. I run them using like an FOC style, and they run really hot if I run them at anything above 50%. This motor I can run at 40%, and that stays nice and cool. The right ascension motor has a lot more weight on it, so I need to run that at 60%. But then I need to have a fan sitting on that just to cool that down. But still, you can see how that is. Yeah. So I mean, this works. Basically, I have them in a stall position, and you have 30 magnets. That gives you 15 poles or 15 segments at which you have a stall position. That means that if I have it here, I can move this around 15 slots of 24 degrees to get one mechanical revelation. And well, basically that means that I'm in a stall position, like an equilibrium position, electrical balance position, if you will. And yeah, it's that's why I get this kind of wobbly motion. Without encoders to correct for that, that's what you have. Yeah, the only way to get that better is if you have, say, a stronger motor. You have a motor with more magnetic poles to decrease this. Well, the number of slots that you have for this. Yeah, and if it's stronger, then that would be a more strength holding it inside that slot. If that makes any sense. So my plan ahead. Oh yeah, look at that. 60 volt, 2 kilowatt BLDC out motor. Oh yeah. So from a scooter, I'm going to use. It's a little bit different in style since this actually has a 2-axis. Yeah, so I'm going to have to work on a mount, way to mount it, and attaching the rest of the OTA and the mount head on it. Yeah, it's going to be a bit of work. But first things first will be to test drive it, see how it behaves, and for that I'll probably need to dissect that mount. This is like 10 kilos. Those motors are 2 kilos. So good thing is that as I built this, the motor will actually not be a part of the moving mount head. It's going to be attached to the base. So the weight of this, the right ascension motor, will not actually add to the instability or anything in the mount itself. More like it's going to add weight to the mount, which might make it a little bit more stable, perhaps. So that's it. We'll get back once we got a test set up. So we are now going to disassemble this old boy. Yeah, I'm going to take the control boards off and get the declination motor off. going to take this, cut this out properly, just basically angle grind that whole piece out, and then we're going to weld this to, going to be somewhere like this.
Well, you know what we say, the bigger the blow, the better the job. I'm doing a fairly good job here then, yeah?
In the shadows I wait just to pull you under. I know it is me. I'm wild and free, and I will keep on crawling, right out falling. All that I need is a drop of water.
Alright, so we're going to do a very scientific measurement here of the force of the motor. So basically I just have the arm here about 46 centimeters long, and it's got a blue string attached to a dumbbell via a luggage scale. Yeah. So the arm is not in 90 degrees or parallel to the floor, but the weight is placed a little bit under, so the rope there is pretty much 90 degrees to the arm. Yeah, so anyway, super scientific. So yeah, and I'm gonna publish a little table of the outcome here. So I'm basically changing the duty cycle, or the force of the motor between each measurements, and I'm in steps of about 10%, so I'm doing it at 10, 20, 30, 40 and 50%, measuring the load of the on the luggage scale, and the current by a clamp meter to the motor. Yeah. Here we have our setup. On the left side we have the right ascension, left, right ascension, anyway, so with the lever arm that's balanced, and on the right side we have declination, also balanced. So we're going to do the same thing with declination here as we did with the right ascension. Before, we're going to have a luggage scale, hook it up to a dumbbell, pull it until it can't pull any more weight off the dumbbell, and we're going to check the current to the motor with a clamp meter. Yes. And we're going to produce a table. Alright, so if we compare the two motors here in a simple table, you can see here to the left it's the small 350 watt motor, and to the right is the 2 kilowatt motor. So just to go through this quick, 2 amps, and the small motor produces 0.5 kilograms of force, yeah, has a torque of about 2.3-ish Newton meters, and at 5.6 amps it produces only 0.9 kilograms, or 4.1 almost Newton meters in torque, while the large motors at a mere 0.9 amps it produces 1.3 kilograms, about 5.8 or 9 Newton meters in torque. And if we estimate like to the maximum of the small motor, 5.6 amps, that would be correspond to, well, somewhere around 4 kilograms of force, yeah, and you would have like a torque of, well, 18 something Newton meters. Yeah, that is crazy. 4.5 times the small motor, yeah? Right then, so looking at the motors here head to head, the large motor here, the axle is not perfectly put on. I can actually slide, the arm can slide a bit on the axle. So if you move it all the way to the flat part of the axle, you can force it between the segments. You can see the whole bend shake. That's so powerful. While this small one is just pathetic. I can just flick it with a finger between the segments, and it's so weak. So weak. Yeah, the other one, the large one, it's quite. It doesn't get very warm. The small one gets quite warm, but the drive circuit is nice and cool, even without heat sinks. The right ascension motor needs a little bit of heat sink. Yeah, there's a bit of heat there, but it's okay. That's fine. Yeah. Yeah. So.
So we're doing it. We are doing it. We are taking the head off the mount to repurpose this for our own mount. Oh yeah. It's crazy? Probably. This piece, it's much smaller. Yeah. Still want to use that. So I'm gonna have to put in some some spacers in there. So the head alone is 12.5, roughly. Yeah, so that motor and the other motor is pretty much the same as this, and then you have some other pieces. So actually not that much out, I think, maybe. A little bit. It's going to be a little bit heavier, but yeah. So that's fairly cool, yeah. Something to start on of, yeah. So this is going in a bag.
So, repeating time, yeah? Oh, I'm excited. So excited. Ta-da! The Lucid Mount 2.0. Yes. Can you see it?
Yes, you can see it. Awesome.
So, here it is. Built on the CGX tripod and tutorial wedge thing. Adapted, sturdy, nice. Probably the nicest part of the CGX mount, if you ask me. If this all works, then this is probably the best upgrade I've done to it. Yes. Well, the rest of the stuff ahead is in the box, waiting for a new MCU. See if I can get it running. Maybe I'll sell it. If this works, I'm never going to put it back here. Or I do is sell the whole thing when I make one anyway. So this is it. Yeah, new motor, massive right ascension motor.
Take a little swirl around here. Get a better angle. Yes. Look at that. Yeah. So pretty happy because we have like all internal wiring almost.
from the head up through the T-slot aluminium profiles into the big black box. Pretty much everything I do ends up in a black box, really. I'm sure I'm going to end up in a black box one day. But yeah, except this part then is like from the declination motor and then some to USB hub external wiring. The rest is pretty much OTA stuff, like camera, imaging camera, guide cable, still using guide cable. So that's it. Powered by 230 volts coming up to the power supply you have right there. Yeah, so that is the only cable that comes out to the mount. Yeah, haven't tested it yet. No, it's done like my little laser dot thing on the wall, and just had it pointing at a sun lounge a share 100 meters up the road here to see how it actually moved, so I can get a good like motion estimation. So we are doing some testing here. The Lucid Mount, it's on a 100-meter distance down there in the garage, pointing up at a reclining chair. Yeah, this is it. I'm gonna sit you down, do some swirling about. Yeah, see if we can make it behave. Full speed. This is crazy speed. To a slight more comfortable speed. It's a bit jerky now, and that is mainly because we're running this in a silent mode when we're around it, working on it, etc. The actual mode that you need to have when you're running on a target is sounding something like this. Yeah, suck on that. It's very noisy, 1 kilohertz with the big 2 kilowatt. It's not actually one, I'm not driving it in 2 kilowatt. That is crazy high noise, but that's what you need to get the accuracy and tracking that you want, which we do. Yeah, so as you can see, I'm still fucking hell. Let's just but we can, yeah, let's just drive it in like high speed around. So here it's a lot smoother when you're running it in that mode. The smaller declination motor is still a bit jerky, and that is because it's got a lot less magnets, really. But that's it. So, what you say, yeah? Thing of beauty. I love it. Yes. Well, I love it right now. Let's see what comes out of it. Yeah. If it works, it's the best goddamn thing I've ever done to that CGX mount so far. Yeah. Yes. Stick it in a box. Forget about it. No. Anyway, so this is it. And right now it is time. Yes. So, cheers, guys. Welcome back, and we'll take a look at something else at some point here as soon as we can. So, till then, may the darkness be with you.